10.3 Quotient of powers property. Quotient of powers property is defined as to divide powers with the same base. You subtract the exponents. So let's look at a couple examples. If you have 4 to the 5th power and divide that by 4 to the 2nd power, that becomes 4 times 4 times 4 times 4 times 4 in the numerator, so you have 5 4s in the numerator, 2 4s in the denominator. You can simplify by taking out 2 4s from the top and the bottom, and then you are left with 4 times 4 times 4, which is 4 to the 3rd power. Or you could have looked at it as 4 to the 5th power divided by 4 squared by subtracting those exponents. 4 to the 5th minus 2 equals 4 to the 3rd. You have the same answer for both of these. You'll just notice that the bottom step where you subtract the exponents gives you less work. So example 1, dividing powers with the same base. A, B, and C, we're going to simplify the expression and write our answer as a power. So 2 to the 6th power divided by 2 to the 4th power. Well, I'm going to show the method both ways. So I'm going to put 6 2's in the numerator divided by 4 2's in the denominator. I'm going to cross out my like terms. So I got rid of 4 2's in the numerator, 4 2's in the denominator. I am left with 2 times 2 in the numerator, so 2 squared. Or you could have solved it as 2 to the 6th power minus 4, which is 2 to the 2nd power. Again, same answers, just different ways of doing it. So for letter B, instead of me writing out -7 9 times in the numerator and -7 3 times in the denominator, I'm just going to go straight to my shortcut. My base is -7, so I want to keep that the same. Then I want to subtract my exponents of 9 minus 3. So that gives me -7 to the 6th power. For letter C, I could make it to where I expand out 7 h's in the numerator and 6 h's in the denominator. But in this case, I'm just going to use the shortcut of if I have the same base and I'm dividing them, I'm going to subtract the exponents. H to the 7th minus 6 gives me h to the 1st. Or you could just have it as h. Example 2, simplify an expression. So we're going to simplify the expression, write it as a power. Well, this time it's not just dividing. You're also multiplying in the numerator. So 3 to the 4th power times 3 squared divided by 3 to the 3rd. Well, I'm going to start with my order of operations and multiply the numerator first because I want to combine my like terms. So if it helps, put this in parentheses. 3 to the 4th power times 3 squared. I want to add my exponents because I have two bases and I'm multiplying them. 3 to the 4th plus 2 equals 3 to the 6th power. Then I'm just going to bring 3 to the 3rd power over each time. Now I have 3 to the 6th power. Now I have 3 to the 6th power divided by 3 to the 3rd power. Well, I have two bases that are the same, and I'm dividing them, so that means I subtract the exponents. 3 to the 6th minus 3. So 3 to the 3rd power. Because it wants my answer written as a power, I can just leave it as 3 to the 3rd power. Example 3, simplify an expression. So we are going to simplify this expression. Now there are multiple ways of solving it. I personally am going to divide each of my fractions first, just because it looks like I have two fractions. A to the 10th divided by A to the 6th times A to the 7th divided by A to the 4th. So I'll begin with A to the 10th minus 6. Again, I'm starting with my first fraction over here. Then for my second fraction, A to the 7th divided by A to the 4th So times a to the 7th minus 4. Again, I'm subtracting those because they are being divided. This simplifies down to a to the 4th power times a to the 3rd power. Now I'm multiplying both bases, so that means I add the exponents. A to the 4th plus 3. My last simplified answer is a to the 7th power. So now you guys are going to try some problems on your own. There are a total of 9. So let's take a look at letter F. 9 to the 7th divided by 9 to the 4th. I'm subtracting the exponents because I'm dividing the bases. So that's 9 to the 3rd power. Letter G, 4.2, that's my base for both of them. I'm dividing, so I'm going to subtract the exponents. So 4.2 to the 6 minus 1st power equals 4 and 2/10 to the 1st, or you could have it as just 4 and 2/10. Both are appropriate answers. Letter H, -8 to the 8th and the quantity -8 to the 4th. We're dividing both of those values. My base is -8. I'm going to subtract 8 minus 4. So the quantity -8 to the 4th power is my final answer. Letter I, x to the 8th divided by x to the 3rd. X to the 8th minus 3. Same base, so I keep it and I subtract the exponents. So that's x to the 5th power. All right, letter J, 2 to the 15th divided by 2 to the 3rd times 2 to the 5th. Well, this is a multi-step expression. So I don't have anything to simplify in the numerator right now, so I'm just going to say 2 to the 15th divided by the denominator 2 to the 3rd times 2 to the 5th. I keep the base of 2 and I add the exponents of 3 plus 5. And that's because I'm multiplying those. So then 2 to the 15th divided by 2 to the 8th. Now I'm dividing the same bases, so I keep the base of 2 and I subtract 15 minus 8. 2 to the 7th power. Letter K, d to the 5th divided by d times d to the 9th divided by d to the 8th. I'm going to rewrite this, and I'm going to put a d to the 1st in my first fraction. Okay. I have d to the 5th divided by d to the 1st, and then I have d to the 9th divided by d to the 8th. I'm breaking them up into fractions. So I'm going to start with, hold on, technical difficulties. Let me reload. Okay, so d to the 5th minus 1 times d to the 9th minus 8. The first fraction, d to the 5th divided by d to the 1st, that's the d to the 5th minus 1, because again, I have the same base of d, and I'm subtracting 5 and 1. Second fraction becomes d to the 9th minus 8. Simplified, this is d to the 4th times d to the 1st. So because I'm multiplying both bases, I add the exponents, d to the 4th plus 1. So that becomes d to the 5th power. Let's try letter L. Simplify this expression. 5 to the 9th divided by 5 to the 4th times 5 to the 5th divided by 5 squared. Again, if colors help you, go ahead and use that. If they don't, that's okay. So I'm going to take 5 to the 9th minus 4 times 5 to the 4th minus 2. Again, when you have the same base and you're dividing, you subtract those exponents. So 5 to the 9th minus 4 is 5 to the 5th, times 5 to the 4th minus 2 is 5 squared. Same bases I'm keeping, and because I'm multiplying, I'm going to add the exponents. So that becomes 5 to the 7th power. Letter M, 5 to the 12th times c to the 10th times d squared divided by 5 to the 9th times c to the 9th. Well, for letter M, I'm going to break this problem up into putting my like terms together. 5 to the 12th divided by 5 to the 9th times c to the 10th divided by c to the 9th times d to the 2nd divided by 1. Now for this last one, you'll see d squared divided by 1. I divided it by 1 so that way I had a fraction. So now I see that I am dividing my bases of 5, so I'm going to subtract them. 5 to the 12th minus 9 times c to the 10th minus 9 times d squared. Now continuing to simplify, 5 to the 12th minus 9 is 5 cubed times c to the 9th minus 9, c to the 10th minus 9 is c to the 1st times d squared is just d squared. My last step is to make this 5 cubed c d squared. Now you could have a 1 with the c, that would work as well. Letter N, 5 to the 15th times y to the 9th, that quantity squared, divided by x squared times y squared, y to the 6th. Well, the first thing I have to do is distribute this 2 to the 15 and to the 9. So we learned this earlier in this unit. By distributing that 2, I'm multiplying. So that's x to the 15th times 2 times y to the 9th times 2, dividing it by x squared times y to the 6th. So that becomes x to the 30th, y times y to the 18th in the numerator, divided by x squared times y to the 6th in the denominator. I'm going to break this into two fractions, x to the 30th divided by x squared times y to the 18th divided by y to the 6th. So I'm going to subtract my exponents now because I'm dividing my bases. So that leaves me with x to the 28th, y to the 12th. So we're going to try a real-life application. The projected population of Tennessee in 2030 is about 5 times 5.9 to the 8th power. We're going to predict the average number of people per square mile in 2030. So let's write down some important information. People per square mile. Or you could write that as MI squared. That's going to be the population in 2030 divided by the land area. So I need to reread that problem and figure out what's going to be the population in 2030 and what's the land area. Well, I can see from my little picture over here that the land area is about 5.9 to the 6th power square miles. Then the projected population in 2030 in Tennessee is about 5 times 5.9 to the 8th power. So I want to simplify this by dividing them. Now, if you notice, we have some commonalities, which would be this 5.9 to the 8th divided by 5.9 to the 6th. So I'm going to break this into two fractions, just like I have before, as if they were letters or variables. So 5 divided by 1 times 5.9 to the 8th divided by 5.9 to the 6th. Well, this becomes 5 divided by 1 times 5.9 to the 8th minus 6. So 5 times 5.9 squared. Now, I don't want to leave my answer like this. I actually do want to calculate it, which when I do put that in the calculator, this gives me 174.05. Well, you can't have 0.05 So 5/100ths of a person. So I'm going to round it, but I'm actually going to round down. So approximately 174 people per square mile.